Now I would like to call our fourth speaker, Mr. Dilip Chewathe, gear consultant from Gear Consultancy. The topic is pitfalls in the design of internal gears. I would like to welcome Mr. Dilip Chewathe on stage. Thank you.
Good afternoon, everybody. I am Dilip Chewathe from Gear Consultancy, Mumbai, and I am going to talk on the pitfalls in the design of internal gears. Now we are talking about spur and helical gears. Basically there are two types of arrangement here. One is a straight parallel axis arrangement and the other one is a crossed axis arrangement. What I am talking about is parallel axis arrangement today, not on the crossed axis. Now you have two types of gear pairs. One is external and external and internal. When you are designing external gears, it's very simple to design. There are not many major issues. Only the issues are, one is undercutting of the tooth when you have small number of teeth on the gear. Then you should have sufficient crest width at the tip diameter, and you should have sepia, which is also called as sap in the normal English literature. It is the start of active profile in action. That should be greater than the sip diameter. Sip is the start of involute profile. That means all the time you are using the involute profile in action. Now points A and B, that is the undercutting and the crest width, these points can be very easily taken care of by judicial use of the addendum modification coefficient. If you have a teeth less than 17 and it's a standard gear, you would have undercutting. But if you use positive addendum modification, you can go down as low as 11, 10, even 7 number of teeth. But then the choice of addendum modification has to be proper. Similarly, in the top crest width, you have to make sure that the crest width is sufficient. It is at least 0.2 times the module of the gear. If it is less, then the tooth can be having a breakage problem at the top. Now, the point C is, that means having the sepia diameter or sap diameter greater than sip, that the tool designer takes care of during the design of the tool, so that he is given the sap diameter. Accordingly, he can design his tool to get the start of involute profile on the gear. That diameter should be less than the sap diameter. Now these are the standard formulae. If people who are not interested in the formula can skip this. This gives you the minimum number of teeth that you can have for given pressure angle psi and the helix angle beta. Now HA star is the addendum coefficient for a basic ISO R53 rack. It is 1, and the addendum coefficient is 1.25. That means your clearance coefficient is 0.25. K is the addendum modification, or in ISO the X is used in place of K. That gives you the value of Z minimum that you can cut when you have a certain pressure angle, certain helix angle, and certain addendum modification coefficient. Now, if you choose your number of teeth, you can know what K you should use. The other way is to know the value of K for a given number of teeth. What should be the minimum value of K you should have? You can stop me if you have any queries or anything to question. Now when you talk about internal and external gear pair, the pinion is an external gear, so all the problems that I talked to you earlier will be taken care by the same problem. Issues will arise for that design of external gear. For internal gears you have many more issues to be taken care of. And these issues are much more complex and difficult to solve unless you have access to computer power or you have access to standards. The DIN standard 3993 gives you what are the permissible addendum modification coefficient for certain gear pairs, but these are only limited pairs. If you have a choice of gear teeth different from what is given in the those standards, you have to interpolate. Whereas the software that is being launched by me, you can do it calculation for any number of teeth. Now, before we go in discussion of this, because there are certain formulas used, you have to understand the sign convention in defining the addendum modification coefficient. There is no standardization on this, whether it is ISO, whether it is DIN, or whether it is French or American standards. So what I have defined, and which is what the DIN standard uses, that addendum modification is considered to be positive if it increases the tooth thickness on the reference diameter. That means your tool is moved towards the tip diameter. But if you take French standard, if the tooth tip is moved towards the center distance, that means towards the thing for internal gear, it is just exactly opposite sign to what DIN specifies. So you have to be careful when you follow the formulae given in any book, what is the sign convention used. If you don't use that, then you will have wrong results. And it is considered negative if it is decreases the tooth thickness when on the reference circle diameter. Now the same convention is followed here. In the French it is exactly opposite. Now the second teeth, when you use a formulae, you can have a unified set of formulae for both for external and internal gears. If you define the number of teeth on the internal gear as negative quantity, then the formulae, one set of formulae can be used all throughout the calculation. You don't have to remember separate formulae for internal gear and separate formulae for external gears. What it does is, when you take this convention, your radius and diameter quantities for internal gears will be negative, center distance will be calculated will be negative, span measurement values will be negative, dimension over balls and rollers will be negative, radial dimension over ball and roller also will be negative, radius of curvature of tooth flank will be negative, angular pitch will be negative, gear ratio and transmission ratios will be negative. So if you remember this, you can use a fixed set of formulae for both external and internal. Now when you come to the issues to be taken care, we saw only 3 issues to be taken care in external gear. In internal gear you have plenty of issues. The number of teeth on the internal gear has to be greater than the mating pinion. That's a very obvious condition. It's not it automatically gets taken care of. For pinion, the external gear, we have already stated what are the issues we have to take care. So I will not again repeat those things. For the internal gear, the absolute value of the inside diameter, that means the inside diameter of the gear, has to be greater than the base circle diameter. Otherwise you will not have the full involute profile extended up to the tip diameter. That's one condition needs to be taken care of. It doesn't come in the case of external gears. The end of active profile in action, that means EPIA, also called SAP in the normal literature, they don't distinguish for internal and external gear, has to be in absolute terms less than the end of involute profile. This is also so that you have all the time involute action throughout the engagement of the gears. The hands of helix of the mating gears has to be of the same hand for internal gear pair. For external gear pair, they are of the opposite hands.